Hi, Assalamualaikum. Um, this is discussion on the tutorial question number 7, nuclear physics. So this is a question related to the finding age of the wood timber. So they found maybe the very old timber that used for the ancient shelter. So the sample of the wood is analyzed for its carbon 14 content. So we try to find the carbon wood trace. So then give 2.1 decays per minute. So this is the uh, uh, information that we need. And then to make a comparison, they use the recent one sample, but the same type of wood. So same type of tree, and they found that this have the decay 5.3 decays per minute. So these two actually is a decay activity. So the question now is age of the sample. So believe that the age of the sample for the first one here, that used on the ancient shelter. So now equation that we use, n equal to n naught exponential minus lambda t. Lambda is the decay constant, and n is equal to a over lambda, which is a the activities, and lambda is the decay constant. So the few information that we can put here. So we have activity for t. Okay, that t, that's something that we will try to find here, which is equal to 2.1 decays per minute. Decay. So decay per minute. And this one we call as a naught, 5.3 decays per minute. Another point that we need to put here is half-life for carbon 14. Okay, the half-life for the carbon 14, around 5,730 years. So we try to find T. This is a example. We try to find this T, the value of T. So what we should do, because we have a value of half-life T half here, and then we have a value of A. We have AT and A naught. So here for n equal to n naught exponential minus lambda T, for n equal to A over lambda, n naught equal to A naught over lambda. And the lambda both are the same because of the same type of the material. So we can put everything here equal to A over lambda. A, we can believe that this is AT, is equal to A naught over lambda exponential minus lambda T. Cancel out lambda, right? Because both have lambda, can times lambda, they cancel out. And we have AT equal to A naught exponential minus lambda T. We can bring A naught to the left. We have A T over A naught equal exponential minus lambda T. And to clear out the exponential, we can make here, because we try to find T here, okay? So here we have, we can put here ln, okay, ln AT over A naught, and this one is equal to ln exponential minus lambda T. Ln exponential is equal to minus lambda T here. So we have ln AT over A naught is equal to minus lambda T. So we try to find here t. So what can we have here? T is equal to minus 1 over lambda ln at over a naught. Clear out the minus, we can have 1 over lambda equal to ln a naught over at. Okay, you can revert this. Another information that we have here, we have half-life. So we remember the equation for half-life. Here we have T for half-life is equal to ln 2 over lambda. We know the value of lambda. We can bring here lambda here. Lambda is equal to ln 2 over T half-life. And then ln 2 is equal to 0.693 over half-life. Alright. So half-life for carbon 14 is 5,730. And we replace a lambda here. So the new equation for T, we can have here T is equal to, okay, lambda is ln to 0.693 over T half. T half-life, it will be 5,730 years. Okay, the unit will be years. Ln a naught over at, we can see that a naught is equal to 5.3. At is equal to 2.1. So 5.3 over 2.1. You can use your calculator here. What we get here is 7.65 times power of 10 power of 3 years. So around 1, 2, 3. So we can say that around 7,650 years. It's long time, right? So this is the answer. So my question will be, this one in unit in years, this one is decay per minute, this one is decay per minute. So why everything in the different units? So that will be my question for you. Okay, see you again. Assalamualaikum warahmatullahi wabarakatuh.